Alright, mastering Solidworks, using assembly tools. SolidWorks assembles enable you to take advantage of several tools in addition to standard and best known functionality. Tools covered in this chapter are general tools that have wide application throughout easy assembly topics. In this chapter, you will learn to assemble without mates, using interfering options, use performance evaluation, features in assembly using sensors and align holes. Placing parts without mates. Assembly mates are a great tool, but they aren't the only tools for placing parts in assembly. Sometimes you may need to place a part without playing a mate, such as when you are setting up an animation. The mate would prevent the animation from working correctly. You might also want to place a part and allow motion of the part is placed relative to while making sure the part itself remains stationary. In a perfect world, assembly mates are as well as controlled, easy to understand, but in reality, sometimes things happen that you cannot explain. If you build an assembly without mates, with this part simply positioned in space using techniques that work, parts are guaranteed not to move unless you accidentally move one. A setting found in Tools and Assembly enables you to turn off click and drag method over the move parts. It requires you to click the toolbar button to enable the cursor to move the parts. If you have the parts in assembly with a place nothing to hold their location, if you have 3D mouse device, one option available is the 3D mouse to move the parts in an assembly when one is selected. When this method is used to move a part, SolidWorks undo command cannot undo moves made in this way. On the other hand, if you design changes you want a set of parts to move together, they will not. You have changed their position, whatever means you used to get them their current positions. As a final touch, for assembly parts having nothing holding them in place, you might consider fixing parts in place. Use the fix and float commands with parts is easy, and knowing that parts will not move brings peace of mind. There is also a locked mate, which creates relations between selected parts but allows those parts to move relative to the other parts. Using move component options, now we see the white cylinder, white prism move to the yellow prism. Move component, several options locating parts without using mates. These are options shown in figure 17.1. Selecting position option, move component. Move component, smart mates, and move free drag along X, Y, and Z along any by delta X, Y, and Z to position X and Z. Rotate, standard collision drag. Detection, physical dynamics, dynamic clearance, advanced option, highlighted faces, sound, ignore complex surfaces in this configuration. This section describes how to use the free drag along with assembling X, Y, and Z along any method to move the component command. These methods are available in the rotate section, movement component property manager interface. Both move and rotate enable the selected drag collision detection, physical dynamics under the option selection section. Collision detection, physical dynamics are described in later section of the chapter. This method describes in the section the moving components assume the use of standard drag option. Using free drag option move component enables you to simply move the part around in the screen by dragging with the cursor. This is the same difficult function of the cursor when in assembly. Clicking and click part and drag. The part follows existing mates and moves the part in 3D space for the part with completely unconstrained with the move of the plane parallel to the screen. If you're viewing the assembly such that the screen isn't parallel to any standard plane, the part you are moving may be moving in and out of the assembly in some other unexpected manner. If you have some mates applied with the part, it's likely to do something odd. You might consider the use of the 4-view option to move the odd parts using this method. Free drag is not a great method to precisely position parts, but it's okay if you are just trying to position something visually as a prop for rendering. Moving along assembly X, Y, and Z. When you drag parts assembly along the X, Y, and Z option, enable the part can move only with the X, Y, or Z axis at one time. It cannot move at any angle. To use the option properly, you should use the orthogonal view so that easier you get the part going with the correct direction. Easier to see with which direction it's headed. Again, using the 4-view display open would also be helpful. If you want to change direction, you must stop dragging the restart with the drag, getting the initial direction with the drag direction you want to move the part. Moving along an etny. Along etny option of move component similar with along X, Y, and Z option, except that the select custom direction part can move only back and forth along that direction. The custom direction must be either linear or planar. It can be an edge, axis, face, place, plane, sketch line, and so forth. Moving by delta x, y, and z. By delta x, y, and z method, the first offers for the direct numerical input with the moving part. Delta means change of the numbers you enter for the change of position part along the specified axis. Figure 17.2 shows the property manager interface for moving parts on the option. Because of this first move option, that uses the apply button shown in figure 17.2. You can move a section of parts multiple times, just entering a number in one of the boxes and clicking apply multiple times. Each time you click applies it by the amounts listed in there are three boxes X, Y, and Z. Remember that you can create selection sets. This include parts and sub-assembly. Save the feature and include the parts assembly. This does not work in the same way with the modified dialog box for dimension, where if you change the number and click the check mark, the dimensions change from 3 to 5 inches. If you have 3 inches in the X box and click and apply, it moves to 3 inches. If you change the X to 5, click and apply it again, it moves to 5 inches for a total of 8 inches. And the second time you have used negative 5 instead of 5, the total movement will be 2 inches in the opposite direction from the original 3 inches. Notice the interface does not have a selection box to tell which parts you want to move. To select the part to move, you can select the face for the graphics window, select the part and sub-assembly feature manager. Click apply moves all of the parts selected. You can change the selections while command is active. So you can move the one selection of parts and then move the different selection. Alright, show the move component using by delta X, Y, and Z. This is the move, and it shows X, Y, and Z. Rotate, options, standard drag, collision detection, physical dynamics, dynamic clearance, advanced options, highlight sound, or complex surface with this configuration. Using XYZ positions. Using the XYZ position option is different from being delta X, Y, and Z. You find this option view, it has a few quirks, and for intended to move the selected point and selected part of the XYZ location key with the X, Y, and Z boxes. Again, the property manager does not have the selection box to list the part of the move points of the move. The specified X, Y, and Z location makes the interface a little more limited with some of the other options. If you don't know how to select a point on Solidworks, assume that you want to move the origin of the part of the multiple parts selected. Assumes that you want to move the center of gravity of the combined parts. And if previous move that you do have the point selected on an instance of the part you have moved a different instance, Solidworks assumes you wanted to position the same point on the second instance of the part. The rules of which points get positioned are not spelled out, too difficult to follow. If I were to use this option, I would position only origins and points. If I were to change between origin and points, I would cancel the command and restart. You can select multiple parts by selecting the assembly feature manager. However, it does not allow you to select points to position anywhere. If you select a point on part, then want to change the different point on the same part, you can't do that. You have to first select the point on another part, and then select the different point on the original part. In general, this option appears to be underdeveloped. This means that you may not have all of the flexibility for working and might appear to have quirks, but it does not follow the perfect workflow process every time. Using the move with triad. Move with triad tool is a different way of moving copied bodies. Feature move with copied bodies is found with the part environment intended to help you individual solid surface bodies, but using triad arrows, wings, rings. Shown figure 1730. Another difference between move and copied bodies and move with triad is move copied bodies creates a feature in the tree. The move component does not. In figure 713, it shows the triad move the body works the same as it does with the triad. So you have these different rings, X, Y, and Z. Moving triad, unlike the movement component, is available only with the right mouse button menu on the parts of sub-assembly graphics window feature manager. On some menus, such as right menu button feature manager, but not right mouse button in graphics window, you will have to expand the menu if you're using a truncated menu. Move triad enables you to move the component dragging along with the worn axis only on the wings. Transparent planes around wings and triad symbols in this display selects the entity being used to rotate the part. Move the cursor around the triad various elements with the tone blue. This reposition the triad and rotate around the different center by dragging dropping the white ball at the origin of the triad. Using for the position only option, the mate property manager has an option called the use for position only, which is shown in figure 17.4. The option has been in software for a long time, but may not be taught in standard SolidWorks reseller classes or demonstrated in most tutorials on the market. This option essentially allows you to go through the motions of creating a mate. However, when you are finished, the part you are positioning will be in place, but will have no mate. The result is similar using any of the tools described in the preceding section of the chapter, but you do not have to calculate the position, movement, amount, and the new position is driven by the geometry on another part. Alright, 17.4 shows using position-only option, mates, coincident and concentric, bite frame, rear assemble, add new filter, show pop-up, show preview, use position-only, make the first selection transparent. The people I've talked to who use this option tend to use visualization to help see the part of the position before the commit method of attaching. Usually people use the position-only option when wind up mating the part completely later. There may be considered the multiple mate strategy to achieve the desired goal more efficient and cleanly. Why would you go through all the work of creating a mate that may not have to show for it? Possibly avoid deleting it later with the avoid conflict that might cause later. For the example, trying to define initial position between the chain link and a sprocket. If you want to link with a concentric sprocket tooth gap, but the certain concentric mate would be would block the movement of the chain when you're using the rack and pinion mate. If you use the concentric mate with a position with an add rack and pinion, everything in it is peachy. If you're working with the reverse, then you're placing without a mate. You should be fixed part with the show that places it with a fix and mates of the parts. Sometimes the animations. You want to place parts placed correctly without a mate interfere with the animated motion of the part. So why wouldn't you create a mate? That just suppresses it? Configurations can be complicated enough without adding configuration just to remove a mate. One case in which a position-only option might be the packaging design. You can place the packaging around the product without mates, so you can use the context techniques without ill effects later. Building parts in place like method of chapter 16, working with assembly sketches and layouts, relatively easy way to place parts without mating them. The technique might be called top-down or in context, and is dealt with other chapters of this book. I mention it here to introduce the method while pointing out the other chapter for details. Alright, using proximity tools. SolidWorks has several tools that are meant to detect property between the parts of assembly: interference detection, clearance verification, collision detection, physical dynamics, and sensors. Using interference detection is available through the menu of the tools. Evaluate interference detection. You can find it with the Evaluate tab. Command Manager is standalone. Shows two parts colliding. The interference detection tool finds existing in interferences in assemblies. Property Manager interference detection is shown in Figure 17.5. After detection, interference is in an assembly. The show of the Property Manager shows selected components, excluded components, results, component view, treat. Coincident interference showed, ignored interference treated. Sub-assembly components include multi-body part interference will make interfering parts transparent, create fastener flaw, create matching cosmetic threads, folder, ignore hidden bodies components, not interfering components, wireframe, hidden transparent, use current. Use two different types of selection interference detection. First side with the top level of assembly feature manager that checks all of the parts of the assembly and interference. For the second method, individual components, parts, and sub-assemblies from the assembly feature manager. In either case, click the calculate button when you finish with this selection ready to use to see the interferences. Display the results. The default result display shown in Figure 17.6 shows each interference where the pair of the interfering components underneath the interference are listed with the size volume of the interferences. So 17.6 shows the interferences and in the component view option. Remember that you cannot judge size of a number just by looking leftmost digit. Numbers are listed in scientific notation 105E005 inches. The third means 1.05 inches, 10 to the negative 5 cubic inches. Reads 1.05 times 10 to the negative 5 power, or very drawn out decimal place of 105 cubic inches. Interferences are not listed in any order, be sorted in size. As you click interference volume highlights right in graphics and windows. You can also right click interference and select the zoom selection if the interference is very small. Ignoring interference is getting ignore interference with the right-clicking interference from the result of the panel with selecting the ignore from the menu, clicking the ignore button with the result panel. You can also ignore interference smaller than. After interference is ignored, simply remove from the list. You can shift the select control select to ignore multiple interferences at once. A counter intermediate with the under result of the list keeps the track of how many ignored interferences there are. After interference is ignored, you can get it back into the result panel. Enabling show ignored interferences option. Option panel ignored interferences are displayed as grayed out. After the grayed out interferences are shown, you can select them in the list using the unignore button, selecting from the right menu, mouse button menu. Look using component view. Component view is an option at the bottom of the results part panel toggles the default display components listed under each of the interference of the component view in which all components are listed. Interference volumes are listed under the component, and under the interferences listed, other interfering part is shown figure 17.6. Selecting options. Option panel shown in 17.5. Most of the options self-explanatory. They are, however, the couple of items now. You cannot do body interference checks with the multi-body parts. You can include multiple bodies in the assembly interference detection. In addition, making interference part transparent option used for the display option on interfering component panels enter the entire assembly is shown in transparent except with the interfering volume which is displayed in opaque. Making interfering parts transparent options turn on. By default, non-interfering components default is in using current display options for non-interfering components. The first panel with the interference detection property manager control the display with non-interfering components. You have the option of making them wireframe hidden or transparent, or you can leave them in display properties alone. I personally prefer the hide option because it offers more contrast to interfering parts to make the interference stand out. It also eliminate fasteners, cosmetic threads. You can create false, unwanted interferences. Notice that though the software does not give the option to distinguish between screw heads and threads, the interference of threads may not be significant, while head interferences are. Alright, it shows the clearance between two parts, and with a dimension line. Using clearance verification enables you to check with the clearance between the parts of the assembly model fixed with the least of the certain amount with the tool list with a certain clearance are less than the clearance you specify, which means identify with the interference as well as clearance of this is for the clearance between specific parts and not between the moving parts. Clearance between moving parts due to the dynamic clearance option of the moving component property bins with described later in this chapter. You can find with the clearance verification tool with the menu tool clearance verification or on the evaluating tab of the command manager with the clearance verification property manager shown figure 17.7. Secret using clarification verifications understand what it measures. Clearance verification is concerned with the clearance less than the distance that you specify. This means the parts you've touched interfere with the list of the clearance in the result box. If you find a minimum clearance between the two parts of the assembly, the tool can do, but you must enter the minimum acceptable clearance box with a larger than clearance of the you're looking for a value of 0. Return all interference looking for the minimum clearance between the two parts. You may get in more intuitive result using dynamic clearance option with a part of the movement component tool. Clearance verification property shown in figure 17.7 in many similar identical interference detection property manager. The result can be fairly similar as well. Typically use the measure tool to find the clearance between the part components. You just select two part components from the tree and start the measure tool. Using clearance verification, you have the assembly, the face, clearance between the selected item, resulting assembly, clearance dimension, results, component, show to ignore clearance treat, sub-assembly components, ignore clearance equals specified value, make parts understanding, transparent, create fasteners, folders, wireframe, hidden, transparent, using current. Alright, using dynamic clearance. The dynamic clearance option is part of the moving the component tool. The move component is on assembly toolbar. The dynamic clearance tab of the panel of its own in the middle of the move component property manager. Use dynamic clearance to activate the selection box shown in 17.8. Pick two parts from the move of the relative to one another. In this case, they're using a fork assembly with the bike model and the download file selecting the fork and the stem. Dynamic clearance parts panel has icons looks like clearance verification described in each of the earlier in the chapter. Clicking the icon enables you to enter the clearance value with the clearance value minimum clearance of the tool. It allows you to move the parts around the clears range of the value of the motion will stop. Note the dimension of the parentheses 1.347 in figure 17.8 with the minimum clearance between the stem and the fork changes dynamically as you move with one of the parts. If you specify the minimum clearance value, Solidworks stops the motion of the part and you're dragging when clearance between the part reaches that number. Alright, you're moving into the moving component dynamic clearance option movement component, free drag, smart mate, selection, collision, the clearance, dynamic clearances, and then assemblies, and then clearance level, advanced highlight sound, ignore complex, surface disconfiguration, using collision detection. Collision detection is another tool with a moving component property. It can be used at the same time the dynamic clearance. You turn on the collision detection in the option panel of the moving component property manager. When activated, several additional options are shown. So the non-collision detection option activates other options. Steering drag, collision detection, physical dynamics, all component check between all components. These components stop at collision drag part only. You can use collision detection, find collisions, give the dynamic assembly motion, dragging parts of the screen, move component using all the parts in assembly. All components just selected over the components. These components obviously there is performance, speed, cost, calculating collisions for all parts, especially for the large assemblies. You just limit the parts of the collision detection if possible. You can also select the option of the stop motion out of in that collision when you help to visualize the more realistic part. Motion of the mechanisms of the drag part only with the option calculates interference only with the drag part with those around it. Activating collision detection also activates other options in the advanced option panel. Highlight faces when the faces collide. They highlight sound. When the parts collide, you will hear a sound. Ignore complex surfaces of the force are created with a loft boundary or other complex method. More time consuming with the calculating interference to prevent diminished performance of the types and faces can be ignored. Using physical dynamics. Physical dynamics may be a bit misleading, essentially the unconstrained free motion collision of the parts, where parts interact to some extent, but they are not real analytical dynamics. Physical dynamics do not take into account any initial velocity and momentum. You can use the physical dynamic clearance only adjustment with its sensitivity adjustment control of the resolution reaction. Because it is a live tool, all of the reactions happen in real time on the drag parts on the screen. Calculation speed factor. Physical dynamics is very useful in the need to find out if the component can be installed or removed from the confined space. One of my customers modeled an engine in place, wondering if it could be installed through a narrow window on site. If you use physical dynamics to test the route and guide the engine out. Alright, the folder with a time clock on it with a red bit. A sensor Solidworks keeps track of several measures available to notify that when the value deviates from high and low limits. You can use the sensor both parts of the assemblies. These type of sensors available in assemblies are simulation data, selecting one or more of the common simulation react with the trigger. Simulation study must be available to sensor type that is not available to SolidWorks standard. You must have the simulation installed license running from this work. Mass satisfies certain relation sensor displays flag. Volume satisfies certain relation sensor display flag. Surface area satisfies certain relation sensor display a flag. Dimensions use a reference dimension, driving dimension, including dimension calculated by equations. Interference detection. SolidWorks looks for interference static parts and assemblies. Measurement. Any value would be normally taken with a measure tool can be tracked. Proximity. If the established sensor locking location, direction, acting distance sensor returns true value of the selected parts passed through sensor. Alright, to add a sensor to the assembly, you must first have the sensor folder in the assembly feature manager shown for the CH17. Feature manager is not there. You can activate it at tools option feature manager. Make sure the sensor folder is set to show. Alright, activating sensors and folder in feature manager. So here is the sensor in the feature manager. Show the dimension number 1. Add sensor, right click the sensor folder to the top of the assembly feature manager. Add sensor. Sensors can be added with the measure tool interface. Sensor property manager shown in figure 17 and 11. Sensor type drop down list expanded. Has mass property, simulation, mass property, dimension, interference, detection, measurement, proximity, costing, data's properties, assembly, pays, value, alert. After you've selected the type of the sensor, add the assembly you select with the parts effective with the option set. The alert shows the notification of the balloon if the value returned by the sensor matches the expression you established the alert panel of the sensor property manager. For example, when reference dimension shown figure 1712 change becomes less of a certain value, SolidWorks displays an alert in the sensor folder. Alright, so now you have an alerted in the sensor folder, which sensor displays and established which meets the established criteria. This is a dimension of 128 at 5.15 degrees. Selecting components. In SolidWorks tool menu assembly addition with a normal selection method such as box lasso select all. There's an entry called component selection. Offers a wide range of methods shown in figure 17 13. You can also exit the tool expanding flyout toolbar selecting icon standard toolbar other places of use such as title bar toolbar. Our selection component selection method of SolidWorks tools menu select magnified lasso box selecting over geometry select all. Verify modified design check format component selection volume select suppress hidden mated to identical internal component size and toolbox advanced select custom menus component items sketch settings tools sketching settings block spline dimensions the relation to dimension experts. SolidWorks does not have an icon-driven activation for these tools, but they are available in the customized keyboard interface, so you can make the hotkey shortcut to them. Selecting the volume. Selecting with the volume. Volume selection option. Have the no dialog box property interface with the workflow for this command goes like putting assembly in view orthogonal rectangular volume that would likely to create selected parts assembly. Pre-select items determine the regulatory volume to start with a pre-selecting point makes the face of the volume go through point pre-selecting plane makes the face of the volume coincident with the face. Initiating volume selection command through the menu of the tool component with the selection volume selected that goes on the step forward even when not a thing appears to happen, no interfering, no change on the screen, no special curve of the cursor, drag rectangular on the screen as you would box selecting items in a sketch. After you drag with the rectangle of the SolidWorks will display a temporary volume with a change with the isometric view. If you draw the original rectangular and isometric view, the rectangular volume will line up with the screen and not on the standard planes. The SolidWorks will rotate the view somewhat and to give you the access to all three dimensions of the temporary with the volume. SolidWorks will display arrows on volume so you can tug and pull the face of the position selecting parts. Use arrows to resize resulting volume on the screen shown in figure 17 and 14. SolidWorks select any of the part completely within the volume the selection made with the volume contains. Parts you do not have anything to activate with the selection clicking outside of the volume will dismiss temporarily to display the volume and will retain the selection. While selection and activation, you can use the command with the right menu mouse button usually. Alright, selecting the volume. Selecting suppressed components. Select all parts assembly with currently suppressed. If you can, the command available to tool component selection. Select suppressed. This command does not have a toolbar button, but you can assign a hotkey through the tool's customized keyboard. The only indication of the parts have selected the features after the parts are selected with the right mouse button with the selection. Selecting hidden components, you can select hidden components just as you would select suppressed components. Again, this command is not interfering with the toolbar icon, but it can be linked to a hotkey. Remember that the hide with the part quickly with the cursor over it. Just press tab to show the part on the cursor where the part should be. Press shift tab. Selecting subassembly. Easiest, most traditional way to select the subassembly is to select it from the feature manager. You can also right-click any component with the graphics area, select with the select subassembly option. And then SolidWorks display with an assembly context toolbar. Subassembly S can also be identified through breadcrumbs interface because of the current selection with the face identified with the breadcrumbs being part of the feature body part as well as assembly, so in current assembly. Selecting parts mated to another, tools and component selection selected mated to, command name suggests selects any of the parts mated with the part that you select after you execute with the command. There's no interface note with an indication of what to do after the section selected mate, the menu option, but for whatever you click next, SolidWorks selects all the parts to mated to. Solid identical components. Identical components can be activated with either pre-selection, post-selection method. The post-selection property manager prompt you to select the component. With pre-selection, when there's no property manager, the identical components are highlighted in the feature manager without account. Selection internal components criteria with the SolidWorks menu with the internal components are not well spelled out. If you run with the selection method of the model, select a couple of parts I would not consider to be strictly with internal parts. Parts are with the seat with a small change ring on the crank. You may have to experiment this tool to get results you expect. Selecting toolbox part. Tools found tools, component selection, selecting toolbox, selects all toolbox parts and assembly, including parts at different levels and sub-assemblies. Using advanced selected options. Advanced selected options have been around a very long time in the software, but it's only with limited use. If you standalone only advanced selection method, but now with all of the options of the component selection heading It's a lot for the company to interfere with the advanced selection of their old dialog box style rather than newer property manager type interface to which more commonly used tools have been updated. Figure 17 and 15 shows advanced component selection dialog box. Shows design and search criteria. Manage searches, delete and clear all name for search and or category 1 category condition value. Define search criteria, condition, and value of the above list for each selected of the components of the current assembly and apply. Alright, you can use criteria with advanced component selection active dialog box to save and the required queries of the search based on the special category conditions and values. 17-15 show the example of setting up the search for the display shade with the edges. Click and apply. Button run search and select with the appropriate manager feature managed example. The category 2 would be we'll use category 1 with file status. Category 2 could be read only write access user with write access needs save out of date. Condition options will be is, isn't, contains, doesn't contain, or so on. Section selections can be reused by using save selection option, which is available through the right mouse button, which adds an entry to the folder of the feature manager. Selection size option allows you to dynamically move the slide of the parts are on a certain percentage of overall assembly size. Figure 716 show the interface was used to facilitate selection. Components that meet requirements are shaded in below. Dialog also tallies how many parts meet criteria. Clicking OK to leave the component selected for whatever you choose to do next. Selecting component size. Percent of the assembly. Dynamic selection selected percentage. Reading assembly performance evaluation results. Alright, reading assembly performance evaluation results. On the left, it shows a bended plane with some arrows from the side. Assembly performance evaluation. Former assembly expert tools provide information about assembly, give the tasks for the parts made for the resolve lightweight components, assembly, subassembly depth, the other information, if may others suggest that things might consider improve the assembly performance. Assembly experts present information in 3 status categories displayed on the left side expert window. Pass is the checkmark warning and the warning and information only. A sample and assembly performance evaluation results window shown in figure 17. Assembly performance evaluation results have been sped up with the performance of your assembly combined with your knowledge of the best practice of assembly. Performance evaluation will never simply tell you what to do. It may suggest that you use the large assembly mode that might tell with the 386 minutes evaluated when assembly is rebuilt. When along with the performance problem, the best knowledge of the should tell you that you might want to do something to minimize the maintenance level of assembly. You should also consider assembly performance evaluation in conjunction with the Solidworks RX, which can point out many system level issues. Alright, performance evaluation, operation, performance documentation, option, file name, configuration, date, time, option time, performance evaluation, performance references, display performances, graphic triangle, assemble, visualization, save, copy, close, and help. Alright, it shows the cut going into a face. Default D feature works on both parts in assembly. It also works in both imported native data. The purpose of this role is to remove geometry detail with improved performance and security when sharing data. Output of the function can be internally stored simplified geometry or simplified geometry set with external file or 3D content central or 3dcc.com is the SolidWorks online sharing library for commonly used data. In the parts, data feature remove small feature selected feature to leave the folder to the top of the feature manager shown figure 17 18. The feature folder associated with the dumb feature of the imported body stored in the file as a separate body. You can see these from the right mouse button menu from the default D feature folder in the feature manager. D feature in the assembly property manager has several steps. Component steps enables you to remove components simply. The D feature of the assembly you can allow SolidWorks to use the automatic method, or you can make the selection yourself. Motion steps enable you to group the remaining parts into groups that work like a sub-assemblies for the purpose of the motion. To keep step D features involve invalid parts of the filling holes, remove the small features, and so on. For removing feature step process, wait the SolidWorks to make all the changes that you have asked to do. Make time to sometimes depending on your computer. Assembly that you're defeaturing defeature parts shows the step 1, start by removing the unneeded components and remove internal components, small components, percentage of the assembly size, selected display, exemptions, components here in the part, planes, left, right, top, bottom, one direction, distance, X and Y degree angles. Step 2, if you want to allow motion in the assembly, control below rigid assembly motion, create group, delete group, mates, section views, direction, dimension, X, Y, and Z. D feature step 3, SolidWorks parts, remove the detailed features, keep up, select all holes, select the holes between, clearance and dimension, tables, and the dimension X and Y degrees. D feature, remove the feature, SolidWorks, remove the internal details. Alright, using a hole alignment tool, which shows a hole in a sectional diagram in assembly. You can find a hole alignment through the measuring tool. Hole alignment on the other evaluate table, command manager. Hole alignment is a feature based on the evaluation tool. It detects misalignment that defines center lines more than given the distance from one another. Then you specify your result. Hole wizard holes. Hole wizard holds simple holes and extruded cylinders holes. Figure 17 and 19 gives the local interference to the hole alignment tool. Hole alignment tool alignment show the cross, the X and the cross, the check and the cross, select the components, hole center deviation, part, result, maximum deviations. This tool does have some limitation, which mostly in kind of holes in which can detect misalignment. Unsupported holes are as follows: multiple boundary extrude, multiple circles in a single sketch with the extruded cut, import geometry created with any of the following: move face, move copy body, split part, mirror body, mirror part, mirror component, part body, pattern body, insert part. This list excludes many of the potential sort of the arrow. Doesn't leave many items of the consequences of the misaligning holes due to the sketch. Hole wizard holes due to other problems. The bottom line: SolidWorks packs a lot of powerful, useful tools in the subassembly environment. Even if you're an experienced user, pays to look through the list. Know that then, because of the new functions are added frequently, you may have new use for an old tool. Master, open the assembly of the bike SolidWorks assembly from the download materials chapter. Use each tool of the tools component selection list in the practice selecting parts and assembly. Volume select, drag a rectangle, then drag it in to create a solid. Volume select, suppress, hit, select hidden, select mated to, select identical components, select internal components selected by size. Master at advanced select select the components with a configuration name that is not default. Invert the selection right mouse button. Highlight the term it should be the first selection in the list. Then suppress all of the non-figured items. Master it. Use one of the selection methods to select multiple components. Save selection as a selection set. Chapter 18, using library assembly features and hole wizard.